All right, let's go ahead and take what we learned in 7.3 with least common denominators and equivalent expressions and apply that to adding and subtracting rational expressions in section 7.4. We're going to look at two different cases. First one is the slightly easier case where we have the same denominator already. So for this part, we won't actually have to use anything we saw in section 7.3. But we are still adding and subtracting rational expressions, but with the same denominator. So just like normal, let's go ahead and look back at just some regular old fractions. So as an example, let's look at 7/15 plus 3/15. And the steps that we use here are going to be the exact same steps that we use when we're looking at rational expressions. So if we go ahead and look at this one, think about what the first thing is you would do just with regular fractions if you already have the same denominator. Well, first thing we want to do is add the numerators together. So 7 plus 3 is 10. Denominator stays the same because we're adding up how many 15ths we have. And then we always want to reduce or simplify. So these are the same steps we'll take with rational expressions. Now, if we go ahead and reduce this, we can divide both of these by 5, and we get 2/3. So let's go ahead and look at what this looks like with rational expressions. So we're told to add or subtract, then write in lowest terms. So even if you forget to write it in lowest terms, a lot of the time the problem's going to remind you anyway, but you should always be doing this whether it asks you or not. So first one here, we're given 3 over y plus 4 plus 2 over y plus 4. So anytime you're adding fractions together, you always want to be able to identify first if you have common denominators, which we do. We should in all of these because that's what we're looking at here, same denominator. So we're going to go ahead and leave the denominator the same. Add the numerator, so 3 plus 2 is 5. And there's no simplifying we can do because we can't factor the denominator. There's nothing to reduce down. And remember, with all of these, if you have addition or subtraction, those terms are stuck together. So even if we could have, let's say we had an 8 on top, we still could not have reduced that with a 4 because that 4 and the y are stuck together. All right, let's try another one. This next one we have a over a plus b plus b over a plus b. Now for this one, if we go ahead and first notice our denominators are the same, so let's keep the denominator. And then this time we don't have like terms on the top. We have an a and a b, but we still want to add these together. So whenever you have terms that are not like terms, you're just going to kind of read them from left to right. So we have a plus b. So we're just going to write a plus b on the top. And we can simplify this one. What do we get if we have the same term on the top and the same on the bottom? A plus b over a plus b is 1. Okay, let's go ahead and try another one here. X squared over x plus 1 plus x over x plus 1. So again, first identifying that we have common denominators, which we do, so we'll keep it. And now if we add across the top, again, x squared and x are not like terms. So we're going to just read across. We have x squared plus x And now for simplifying, remember, in order to simplify, we need to go ahead and factor. We can't factor anything on the bottom. And remember, x plus 1 and x squared plus x right now are stuck together. So we can't just cancel out these x's here because of the addition. So let's see what we can factor out on the top. We can factor out an x. So we're left with an x plus x divided by x is 1. Still have that x plus 1 on the bottom, and I'll put parentheses because it's still stuck together. Now, if you notice, these guys cancel out. So we're just left with x over nothing, so it's just an x. Okay, a couple more of these before we try unlike denominators. And these next ones are going to be with subtraction. So these ones we are going to have to be a little bit more careful. So 3 over m squared minus 2 over m squared. Now, with one like this, when you have just numbers on the top, it's not too bad. Think regular fractions, we just subtract the numerators since the denominator is going to stay the same. 3 minus 2 is 1. 1 over m squared is just 1 over m squared. There's nothing we can cancel. There's no factoring to do. But with ones like the next ones, you have to be really careful. So we have in this one, x over 2x plus 3 minus 3x plus 4 over 2x plus 3. Okay, so if we go ahead and look at the denominators again, they're the same. So let's keep our denominator. And now for this one, notice how we're subtracting this entire fraction. We're not just subtracting the 3x, we're subtracting this whole thing. So when you subtract fractions, you're going to keep your first numerator. So we're going to have an x, and we are subtracting 3x plus 4. So I'm going to put that 3x plus 4 in parentheses. Or you can think of it like we're subtracting 3x and we're subtracting 4. This way is just a little bit better so you don't mess up any double negatives that you might have. And we'll see that in the next one. All right, so now if we go ahead and think about distributing that negative, we're going to have x minus 3x minus 4 over 2x plus 3. And notice how before we try to do any simplifying by factoring and canceling, we're always going to make sure the numerator is completely simplified. So we're going to go ahead and combine x minus 3x. So 1 minus 3 is negative 2, x minus 4 over 2x plus 3. And again, remember 2x plus 3 is stuck together, negative 2x minus 4 is stuck together. And even though we could factor the top, so I could take a 2 or a negative 2 out of here. So we would be left with x. Negative 4 divided by negative 2 is positive 2. Nothing that we get there is able to cancel with the expression on the bottom. So you could factor, but there's no point in doing that for this one. It's always good to check though. You always want to make sure that you can't cancel things out. So this is our final answer here, with or without the parentheses. Normally without, this just helps remind you that these terms are stuck together. All right, and then one last one before we get to different denominators. So with this one, we have 5t over t minus 1 minus 5 minus t over t minus 1. Let me double check one thing here. Yeah, okay, so last one with the common denominator, but it still has it, so we can bring over that t minus 1. And then on the top, we have 5t, and we are subtracting this entire thing. So this is one where it's really important to remember to put it in parentheses, or remember to kind of distribute this negative in, because we're subtracting a 5. So we're going to have 5t minus 5. And if we subtract a negative, we're actually going to add t. Be really careful with those negatives. This is probably the most common mistake with these, is just putting minus 5 and then bringing over this minus t. That's why I love putting in the parentheses here to remember to distribute. All right, and then if we simplify a little bit, 5t plus t is 6t minus 5 over t minus 1. These guys are stuck together, and there's no factoring to do, so this is our final answer. All right, so that is what it looks like when we have common denominators. It's the slightly easier case. Now let's take a look at adding and subtracting. With unlike denominators. All right, so the key thing with this is that we need to find the LCD first. So let's go ahead and look at some examples. We're told to add or subtract, then write in lowest terms as usual. Okay, first one we're gonna do, we're gonna start off with regular numbers. So we're gonna have 1/10 plus 1/15. So first thing I'm going to do is I'm going to realize our denominators are not the same. First thing we have to do is find the LCD. The smallest number that 10 and 15 both go into, and I'm actually going to do this over to the right. I like to work vertically with these. You'll see why when we take a look at our rational expression examples. Smallest number that 10 and 15 go into is 30. So I know that both of these need a 30 in their denominator. Now we're going to see what we want to multiply each one of these by. From 10 to 30, we multiply by 3. So 1 times 3 is 3. From 15 to 30, we multiply by 2. 1 times 2 is 2. And now we can go ahead and, well, let's work horizontally now. Keep our denominator since it's a like denominator now. And then if we add across the top, 3 plus 2 is 5. And then if we reduce both of these by 5, 5 goes into 5 one time, 5 goes into 30 6 times. So find your LCD, write the equivalent expression, and then add the numerators. Okay, let's go ahead and try this with some variables. 6 over 5x plus 9 over 2x. First thing we want to do here is figure out the LCD. So if we look at both of these, remember we're looking at the different factors, and we want the factors the most number of times they occur in just one fraction. So if we look at the numbers first, 5 and 2, the smallest number that 5 and 2 both go into is 10. And then our other factor here is x. Notice how we have 1x in each of these. There's no exponent higher than a 1. That means we need 1x in our LCD. Now, technically, if you put an x squared or an x cubed, something higher, the LCD would technically not be correct because it's not the least common denominator, but you will still be able to get the final answer. You'll just have more reducing to do at the very end of the problem. So still doable, but LCD makes it a lot easier to work with. All right, so we know both of these have to have a 10x. So I always write that down first, put in the arrows, and then we want to see how we get from one denominator to the next. So first, if we look at the 5x to 10x, we have an x, but we need to go from 5 to 10, so we have to multiply by 2. 6 times 2 is 12. And then looking at our next denominator here, again, we have the x, so we're good there. And then from 2 to 10, we have to multiply by 5. 9 times 5 is 45. Now, if we go ahead and add our fractions together, we're going to keep our denominator. 12 plus 45 is 57. All right, so now if we wanted to go ahead and reduce this, the only numbers that go into 10 are 2 and 5 and 10. None of those go into 57, and so this is as reduced as we can get here. All right, let's go ahead and try this with another one. One where the least common denominator is not quite as nice. We'll work vertically, so I'll put it over here. So we're given 2p, and actually I'm gonna give myself a little bit more space. 2p over 3p plus 3 plus 5p over 2p plus 2. Okay, so for this one, first things first, we're adding fractions and we do not have a common denominator, so we need to find our LCD first. But if we look at both of our denominators, in order to find the LCD, we do need to go ahead and factor both of these. So what I'm going to do is I'm going to just replace the denominator and rewrite these fractions. So 2p over, now if we look at this, we can take a 3 out, and we're left with a p plus 3 divided by 3 is 1. Looking at our second fraction here, we can take out a 2. So leave the 5p on top, factor out a 2, and then we have p plus 1. And now if we go ahead and look at our denominators, we have coefficients in the front we can take care of first. So let me go ahead and move this LCD down. 3 and 2 both go into 6. And then what is the other factor that we need to include here? It's going to be a p plus 1. So that is the only factor that we have, and we have one of them in each of our denominators. Okay, now we can go ahead and change our denominators. So we're going to make each of these a 6p plus 1. So I'll write that down first. Now we want to see what we have to multiply by. So looking at this first fraction here, our denominators, we have a p plus 1 already, and we go from 3 to 6, so we need to multiply by 2. 2 times 2p, I'm actually going to leave this as 2 times 2p for right now. I'm going to make the steps a little bit longer for this, but if you wanted to put 4p right there, you could. And then our second one, We have the p plus 1 again, but we're going from 2 to 6, so we multiply by 3. So we're going to have 5p times 3, or 3 times 5p. Now, if I go ahead and simplify the tops a little bit, or combine it in one step, there isn't a right or wrong answer or right or wrong order for those two steps. I'm going to go ahead and simplify first, and then I'll combine our fractions. So 2 times 2p is 4p over 6 times p plus 1 plus 3 times 5p is 15p over 6 times p plus 1. And then once the multiplication starts getting a little trickier, maybe you had to FOIL, you can always do that off to the side and bring it in this step right here. Perfectly fine. All right, now we have our common denominator. Let's go ahead and add these two fractions. 4p plus 15p, those are like terms, so let's combine them. We get 19p. And now if we check to see if we can simplify it all, bottom's already factored, that's why you always want to leave it in factored form. We can't factor the top, and there's nothing we can cancel or reduce because the p and the 1 are stuck together, so we can't cancel these p's out. All right, let's try some more. What number are we on? Number 4. Negative 2 over p plus 1 plus 4p over p squared minus 1. All right, so first things first, if we want to figure out our LCD, we need to factor. P plus 1 is already factored. I'm just going to throw that in parentheses. So we'll leave that as negative 2 over p plus 1. But with our second denominator here, we have the difference of perfect squares. So we're going to set up two sets of parentheses. That 4p is going to stay on the top. And to get to a p squared, we need p times p. To get a 1, we need 1 and then put plus and minus. And now our LCD. Let's look at our factors that we have on the bottom of these fractions. We have a p plus 1 in each, so we need one of those. And then we also have a p minus 1. And again, we have one of those just in the second fraction, but we do need to include it. Now let's go ahead and rewrite our fractions with the LCD. So p plus 1, p minus 1, plus our second denominator isn't actually going to change, so that's nice. All right, so now let's see what we're missing. So we had a p plus 1 in the first fraction. Now we have a p plus 1 times p minus 1. We need to multiply by p minus 1. So if you wanted to do this off to the side, that's perfectly fine. I'm going to write this as negative 2 times p minus 1 though. I'm going to do it in the next step. Plus our second fraction has no change because the denominator is still the same. So I'm just going to bring that 4p down. And now I'm actually going to go ahead and combine these right now. Sometimes this is easier, especially when you have subtraction. So what I mean by that is I'm going to keep our denominator. And then I'm going to read across the top from left to right. So we have negative 2 parentheses p minus 1 plus, that plus sign in the middle, 4p. Now, this expression on the top is something we know how to simplify. We have to distribute. So we get negative 2p plus 2 plus 4p over our denominator. Oh, I'm going to run out of room. And then finally, combine like terms. So we have negative 2p plus 4p is 2p plus 2 over p plus 1. I don't know why my pen does that. P plus 1, p minus 1. And what is the last thing we always want to try to do with these? Simplify. So I'm going to go ahead and just work across here because I ran out of room. We want to factor the top if we can, and we can. We can take a 2 out. So we're left with p plus 1, which is convenient because we have a p plus 1 in the denominator. So we can go ahead and cancel out the p plus 1 and the p minus 1. And we're left with a 2 over p minus 1. So this one had a few more steps. We had to factor the denominators, find the LCD, and rewrite our numerators, combine our numerators, simplify that down, factor again in the numerator, and then cancel out. This is probably more of a typical problem, doing all of these steps. So this one's really good practice for adding and subtracting these. All right, let's go ahead and try another one here. This next one is a little tricky. So number 5, we were given 2k over k minus 7 plus 5 over 7 minus k. So there's nothing we can do to factor these denominators. But one thing I do want you to notice is the denominators already look pretty similar, but they are not the same. So what is the relationship between k minus 7 and 7 minus k? These are opposites. If you remember, when you cancel out opposites, you get -1. What we're going to do here is we're going to keep the 2k over k minus 7. And it doesn't matter which one you change the sign on. So what I'm going to do is I'm going to make that 7 minus k on the bottom a -1 times k minus 7. Now, this step that I just did is kind of optional. You can jump straight to the next step. And I'm actually going to write that as a negative in the front, not a -1. If you think about distributing it, you get a -k and a +7, which is what we started with. Now, if you remember with fractions and negatives, if we have negative, let's say 1/2, this is the same thing as -1 over 2 or 1 over -2. You can put that negative on the top or on the bottom or out in front, doesn't matter. So I'm going to take this negative and I'm going to move it up to the top with the 5. That way our denominators will be the same. So I'm going to keep the 2k over k minus 7 plus move this negative up to the top. So it becomes a -5 over k minus 7. We could have also moved the negative out in the front. So we could have had a 2k minus 5. Just make sure it goes one or the other, but not both. Now we have our common denominator. We can go ahead and combine our fractions. So we have a 2k plus -5. That's the same thing as just -5. Now, at this point, we would try to factor and cancel. There's nothing to factor, and these guys are all stuck together. So we're done. So big thing for this one, my box got erased. Big thing here is noticing if you have opposites in the denominator, you're going to take that negative. You can kind of skip straight to not there, that's not any step. You can just skip straight from this step to this step and just take that term that's on the bottom or the terms, change the signs and move the negative up to the top. You don't have to do this middle step here. All right, number 6. So we're given 6 over a plus 2 minus 1 over a minus 3. So we're back to the kind of normal questions here. We don't have an opposites in the denominator, but they are completely different. We have an a plus 2 and an a minus 3, nothing to factor. So if I go ahead and figure out the LCD, we have an a plus 2 on the left. That's the only a plus 2 we have, so we need to include that. We also have an a minus 3. That's the only a minus 3. We need to include that. Anytime your denominators are completely different and you've already got them factored down, if they're completely different, you're just going to take those denominators, multiply them together because they don't have anything in common. Now, if we go ahead and rewrite both of these denominators, so a plus 2 times a minus 3, and I'll leave myself any room there, minus a plus 2, a minus 3. We want to rewrite each of our denominators, or each of our fractions. This first fraction here has the a plus 2. It's missing a minus 3. So we're going to multiply by a minus 3. And I'm going to go ahead and just write that next to what we have. So we have a 6. We're multiplying it by a minus 3. Our second fraction here, we're going to have a 1 times, now we're missing an a plus 2. Now, did we have to write this 1 here? No. Anytime you multiply by 1, it doesn't change the value of the number or the expression. It does, however, make this one a little bit easier to not mess up on the minus sign in the middle. What I mean by that is if I go ahead and combine our fractions, I'm going to put a plus 2, a minus 3 on the bottom. And if I combine, or sorry, if I follow along from left to right, I'm going to just write what I see. So we have 6 parentheses a minus 3, not simplifying anything just yet, minus 1 parentheses a plus 2. This makes it so that you don't forget to distribute this negative in to both of those terms. So I would always get in the habit of, even if you don't have a 1 there, you'll probably have another number. It'll help you so that you know to distribute. Now let's go ahead and simplify the top so that we can simplify this fraction as much as possible. 6 times a is 6a minus 18. Our next two terms, remember to distribute the negative to both. So negative 1a or negative a minus 2 over our denominator. Now let's simplify the top a little bit. So 6a minus 1a is 5a. Negative 18 minus 2 is negative 20 over our same denominator. Remember, keeping that one factored. Now, if I were to go ahead and factor the numerator here to try to reduce down, if I factor out of 5, we're left with a minus 4. So even though we were able to factor something out of the top, there's still nothing else to cancel out here. So always factor just to make sure that you can't simplify. But at this point, either of these answers would be correct. All right, let's go ahead and try another one. This one's kind of similar to the one we saw before this, number 5. This one we're given 2y over y minus 2 minus 1 plus y over 2 minus y. So first thing here is, what do we notice about the denominators? We have these same terms flipped around with a minus in between. Those are opposites. So I'm going to go ahead and I'm going to show this like middle step here. You don't have to write this. But we're going to keep our 2y over y minus 2 minus 1 plus y over, so I'm going to take out a negative, flip these guys around, so y minus 2. And now what I'm going to do in this one is, instead of putting the negative on top, so if I go back here, remember the negative can go on the bottom, on the top, or out in front. It's actually a little bit nicer if we put it out in front for this one, because it'll make this minus sign a plus sign. So we're going to take this negative and combine it with this minus. Now this only works if the negative is around the entire denominator. So this entire denominator is being made negative. Same thing if you had a negative that was on the top. So let's say we had minus negative 1 plus y over some denominator down here. These two negatives would become a positive. Just like when you're subtracting like a negative 5, it becomes plus 5. All right, so let's go ahead and make this negative a positive. So we have 2y over y minus 2 plus 1 plus y. Now we move this negative up here, so this is now just a y minus 2. Now we have common denominators, so we can add. So let's combine our two fractions into 1. And we have a 2y. I'm going to go ahead and read this left to right. Plus, it's a plus, so we don't have to worry about distributing a negative. So let's just put 1 plus y. Simplifying, 2y plus 1y is 3y plus 1 over y minus 2. Nothing to factor, so there's no simplifying we can do here. All right. Let's go ahead and just try one more of these. What number are we on? We're on number 8. 4y over y squared minus 1 minus 5 over y squared plus 2y plus 1. All right, now we are subtracting these fractions, which means we need an LCD. Before we can get the LCD, we need to factor our denominators. So let's leave that 4y on top. Y squared minus 1 is the difference of perfect squares. So two sets of parentheses. Y squared is y times y. 1 is 1 times 1. Put a plus and a minus. Now our second fraction here is a trinomial, so we can use a big X. We're multiplying to 1, adding up to 2. The only things that multiply to 1 are 1 and 1. And those do add up to 2, so we have y plus 1, y plus 1. Keep the same numerator. Now that these guys are factored, let's figure out the LCD. Now our LCD for this one, if we look at the y plus 1, we have 1 in the first fraction, 2 of them in the second fraction. This time we're going to need 2 y plus 1s. So you can write it as y plus 1 squared, or just y plus 1 times y plus 1. And then our other factor, which only happens one time in our first fraction, is y minus 1. So we do need to include that one. Now let's go ahead and change both of these fractions. So we have y plus 1 times y plus 1 times y minus 1 minus, same thing over here, y plus 1, y plus 1, y minus 1. So we're just writing down our new denominators so that we can figure out what we have to multiply our old denominators by. So let's go ahead and look at our first fraction. We had a y plus 1, and now we have two y plus 1s. So I'm going to take our original numerator, our 4y, multiply it by an extra y plus 1 because we only had 1 before, we need 2. We had a y minus 1, and we need a y minus 1, so that one's actually just going to stay as it is. This is all we need to do for the first fraction. Our second fraction, we have a 5. And let's see, we have two y plus 1s, two y plus 1s. We're missing a y minus 1. So we're going to multiply by y minus 1. All right, so those are our new numerators there. So I'm going to go ahead and combine now. So I'm going to keep our denominator. And now I'm going to read from left to right so that we don't mess up with this minus sign here. So we have 4y times y plus 1 minus 5 times y minus 1. One other kind of common mistake here is people want to cancel out these y minus 1s or a y plus 1 here. The reason why we can't do that is because of this minus sign in the middle. If we didn't have this minus sign and this were all multiplication along the top, perfectly fine. But because we do have this minus sign, you cannot cancel these y minus 1s and y plus 1s. In order to do that, we have to simplify the top down and then refactor. Okay, now let's go ahead and distribute. So we have a 4y squared plus 4y. Negative 5 times y is negative 5y. Negative 5 times negative 1 is positive 5 over our denominator. Now let's combine our like terms on top. So we have a 4y squared minus y plus 5 over the denominator. Now we want to go ahead and see if we can factor in order to simplify. So let's look at this guy right here. I'm going to go ahead and try factoring this up here. So I'm going to draw a little box here. And let's put this 4y squared minus y plus 5. 3 terms, so I'm going to use the big X. Now, we're going to need to multiply to 20, so 4 times 5 is 20, adding up to a negative 1. Now, we're multiplying to a positive, adding to a negative. We would need 2 negative numbers, but any numbers that multiply to 20 would be 1 and 20, 2 and 10, 4 and 5. And if both of those are negative, there is no way that they can add up to a negative 1. This is not factorable, which means this is as far as we can go. All right, so that is a tricky section, but we are almost done with chapter 7. We have 2 more sections to go, and we are going to be using this stuff a little bit in the next section. The next section goes over complex fractions, which are called complex fractions, and they are a little complex. So we'll continue working with these rational expressions in 7.5.